Hi everyone, welcome to this project series in which we are developing a value at risk model using three quantitative approaches that are variance covariance method, historical method, and the Monte Carlo simulation method. So in our last video, we understood how to develop a value at risk model using the variance covariance method. In this video, let's understand how to develop the value at risk model using the historical method. So in the first half of the video, I'll be walking you through the theoretical concepts, and then in the later half, I'll be walking you through the Excel implementation of value at risk using historical method. But before going to the Excel, let's understand the theoretical piece. So what is historical method and how do we use it to calculate value at risk? So the historical method for calculating value at risk is pretty straightforward. So the historical value at risk method is based on the historical performance of the portfolio, or let's say, or it depends on the historical performance of the assets in the portfolio. So the historical value at risk is based on the historical performance of assets in the portfolio. So So basically, if you see this approach, this is this actually incorporates the characteristics and the composition of the portfolio since it depends just on the historical performance. So it so if you see this approach, it inherently incorporates the characteristics and the composition of the portfolio. Also, if you see, right, why do we say, this is a very easy method, or, you might be hearing with when you speak to people, okay, when you speak to risk managers or cons, right, in general, they'll always say historical method, it's the most easiest method of calculating value at risk. And why do we say this? Is because we are not making any assumptions on the on how to, let's say, on the distribution of the data. So if you see in the variance covariance method, which I covered in my last video, so if you have not seen it, I'll highly recommend to watch it. So if you see the variance covariance method, we make a assumption that the return should follow normal distribution. Return should follow normal distribution, right? And see, whenever we make certain assumptions on the distribution, right, then that method is said as parametric method. Okay. So whenever we try to make assumptions on any of the data, so that method is referred to as parametric method. But in this case, right, in the historical simulation case, let's say in the historical method, okay, in the historical method, we are not making any assumptions on the data, right? So it is for that reason it is called the non-parametric method. So just to make you understand, whenever we make assumptions on the data, it is said as parametric, and whenever we don't make any assumptions on the data, it is called as non-parametric method. Okay. So historical method is basically the non-parametric method, which means that it does not require to estimate parameters such as volatility or correlation. So in historical method, so let me represent a historical method by HM. In historical method, we the in historical method, the method does not require to estimate parameters such as volatility or correlation. Because if you have seen my variance covariance method video, in that method we calculate both the volatility and the correlation. Okay, so but in this method we do not need to calculate the volatility and the correlation, and that is why it is said as a non-parametric method. So historical method, that, like, let's understand, because I hope you understand, right? This whole method of, like, the historical method of calculating VaR is solely dependent on the historical performance of the stocks in the portfolio. So I'll be walking you through the calculations, but I just want you to understand it only depends on the historical method depends on the historical performance of the stocks in the portfolio. And because of this reason, right, let's understand the advantage. The first advantage is the historical method is simple and intuitive, because we are not making any assumptions. Okay, we are not making any assumption, neither we are trying to calculate any parameter, right? For these reason, it is, very simple and intuitive to understand. Also, if you see, because we are also not doing any complex modeling here, since the model is solely based on the historical performance of the stocks in our portfolio. So we are not trying to do any complex modeling. Okay, these are certain advantages of using the historical method. Now let me walk you through the steps of how to calculate VaR using historical method. Okay, steps for calculating VaR using historical method. Okay, first step is gather the data. See, let's say you have three stocks in your portfolio, right? So you need to download the data, right? The first thing is, of course, you download the data, you gather the data, right? So then download the, let's say if you have stocks in your portfolio, download the stocks data. So you can download it from Yahoo Finance. This is, the very first step. Second step is calculate the return. So if you see, we can calculate the return basically by using the formula, which is return is equal to price today minus price yesterday divided by price yesterday. So you can use this simple formula to calculate the return, or, just to simplify this formula, you can also write as price today by price yesterday minus 1. Okay, so you can use this formula to basically calculate the return. The third thing is you need to sort the return in ascending order. So let's take an example. Let's say when you, after performing step 2, right? After performing step 2, you got your return as, let's say, negative 5%, negative 6%, negative 4%, negative 3.2%, negative 5.5%, negative 2.1%, negative 1%, then 1%, 2%, 1.5%. Okay. So let's say we got this the returns. Okay. So the how will we sort the return as, if you see, sort them in ascending order basically means from worst to the best. So if you see, the worst is minus 6%, then we have minus 5.5%, right? We have this, then we have this, then we have okay, then we have negative 5%, then we have negative 4%, negative 3.2%. So you just need to arrange this in the ascending order, okay? 1%, 1.5%, and 2%. Okay. So now once you have arranged this, the next step is choose the confidence interval and calculate the rank. Let's say you can calculate the position or rank, whatever you want to say, okay? So let's understand how to calculate the rank. So let's say if we take confidence interval as 95%, right? So how will we calculate the rank? Or let's say the position is n times 1 minus confidence interval, where n represents your total number of trading days. Let's say total number of trading data. Okay. So let's say you downloaded 100 days of trading data, right? Let's say you downloaded 100 days of trading data. So in this case, your n will become 100, right? So now if you see your position is nothing but 100 times 100 multiplied by 1 minus 95%, which is nothing but 100 multiplied by 5%. So we can write 5% as 5 by 100. So this gives us 5. So your position is 5, right? So what you need to do is, okay, just, okay, so let's say we just need to number this 1, 2, okay, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8, 9, 10, let's say, okay. So at whatever your return is at the fifth position, right? That is your value at risk return. Or let's say so if you see in our case we got 3.2 negative, so at position 5, right, the return is negative 3.2%. So that's why our value at risk will be the basically return at fifth position times the portfolio value. So assuming we have our portfolio value as $1 million, so it will be nothing but negative 3.2% times $1 million, right? So just to calculate it, so if you see, this will become negative $32,000, right? So negative basically represent loss. So we can say that our value at risk at 95% confidence interval is negative, or let's say value at risk at 95% confidence interval is $32,000. And since we have taken the daily data, so it will be 1 day value at risk at 95% confidence interval. So this was the methodology of calculating value at risk using the historical data. Let me summarize the methodology. Okay, let me summarize the methodology. Okay, so the first step is basically we need to gather the data. Second step is nothing but to calculate the returns. So you can use price today divided by price yesterday minus 1. Then you need to sort your return. So once you sort your return, right, in ascending order, so this will be your return in ascending order. And just just basically add your serial number. Or you can say just add a rank, or let's say you can say this as position. You're just adding 1, 2, 3 for line row wise. So once you do this, choose your confidence interval and calculate the position. So your position is nothing but n multiplied by 1 minus confidence interval, where n is your total number of trading data you have taken. So let's say you have taken 1 year data, which is nothing but 252 days of trading data, right? So you'll take n is equal to 252, and you'll multiply with 1 minus confidence interval. So whatever position you get, you just need to look out for the return at that position. So in this case, it's negative 3.2%. So you need to multiply the return at that position with the portfolio value to arrive at the value 1 day value at risk at 95% confidence interval. So this was all about the theory. Let me walk you through the practical application, practical Excel implementation of the same. So if you see, the first step that as I said, we have to do is we need to gather the data. So in my portfolio, I've considered three stocks, that is JP Morgan, Morgan Stanley, and Bank of America. So I've just downloaded the data from Yahoo Finance. So we have our data from August of 2022 till August of 2023. So if you see, if we count this, this is like 252 days of trading data. That is nothing but just 1 year of trading data, right? So we basically use the formula of returns that I just showed you back, which is yt divided by yt minus 1, and this whole subtracted by 1. So this will basically give you the stock, the returns of the daily returns of individual stocks, and just you just need to drag this formula till the end to calculate your daily return. So once you have your daily return, right? So now what you need to do is, let's say you have different weights of this, different weights. Let's say we are assigning 30% of our money into JP Morgan, 40% into Morgan Stanley, and 30% into Bank of America, right? So this is nothing but your W1, W2, W3. So just multiply W1, W2, W3 with R1, R2, R3. So in Excel, we have a very simple formula which says some product, which will do nothing but this sum product will do is equal to, the formula will be nothing but W1 R1 plus W2 R2 plus W3 R3. And if you want me to do this, let's say W1 times R1 plus W2 times R2 plus W3 times R3. So this will also give you the same, the same return, portfolio return as of this formula. It's just that Excel has this, you know, some product function. Also, just for you to understand why we are doing W1, R1, W2, R2, W3, R3 and adding it, because we have different weights in our portfolio, and that is why we need to make sure, like, if we are assigning 30% of the money in JP Morgan, so we need to multiply our returns also with 30%, and same goes for the rest of the stocks. So always remember this thing whenever you are trying to model, trying to make a model in the world of quant finance. If you are assigning weights, you need to multiply your weights with your returns to calculate your returns of the portfolio. So you need to multiply your weights, individual weights of the stocks with with the returns of the particular stock, so in this case JP Morgan, and then add them all to calculate the portfolio return. So as I said, once you calculate the portfolio return, right, what you need to do is you need to arrange this time series, this whole return series in ascending order. So how you can do is, let me quickly show you. Okay, so let's say we take this data and okay, let's say we take this data and we arrange this. Okay, so let's say, so what I have done is, let me write this as return. So just enter Control Shift L. So Control Shift L will give you a filter. So just do smallest to largest, right? So once you do smallest to largest, right? Now if you see this this return series is same as this return series. So basically what we are trying to do is we are arranging the return in ascending order. So when you do smallest to largest, it is just arranging the returns in ascending order. Okay. So once you do this, right, you need to add a rank, or you can say position. So how I have added the position is just, add 1, 2, something like this. And what you need to do is just uh, yeah, just go up till the last, whatever last value we have. So this is how we have ranked. So just if you see, we have total number of data is 251, and why is so is because whenever we download stocks data, so if we have taken 252 days of data, we'll always lose one day when we are trying to calculate the return. So that is why if you see, we have total as 251 days of data. So now we have arranged our series into ascending order. Now let's calculate our value at risk using the historical method. So the total number of days trading, total number of data that we have is, as 251, right? Because you can basically count, as soon as you add the rank, or let's say as soon as you add the position, okay, we have total number of 251 trading datas. So once you have your total number of trading data, what you need to do is you need to check the confidence interval. Let's say if we are considering the 99% confidence interval, right? So your alpha, or let's say your if you're 99% confident, then your uncertainty is nothing but 1%. So what we do is we basically multiply, we basically multiply this we basically multiply the total number of data that we have with your uncertainty. So this will give you 2.51. Now, because it is not possible that um, we don't have anything as 2.51, in the position, or let's say in the rank, right? So we just round it up. So we can say, let's round this 2.5. So round whenever we apply this roundup function, it will give us 3, right? So 2.51 roundup is 3. So we just need to look at the return at the third position. So this is nothing but your 3 points negative 3.63, right? So once we get this written at the specific position, you just need to multiply this with the portfolio value to arrive at the value at risk number using the historical method. Similarly, if you see, uh, we have taken here, what we have taken here is 95%. So when your certainty is 95%, your uncertainty is 5%. Always make sure your certainty and your uncertainty combined will be 100%, right? So, the next step is of course calculating the position, which is nothing but you multiply your trading data, number of data points you have with your alpha value, or let's say with your uncertainty period. So this will give you 12.55. So you just need to round it up because we do not have any 12.55 position. So once you round it up, you just need to, you get 13. So you need to look at the returns at 13 position. So if you see here, the returns at 13 position is negative 2.42%. So then once we get this return, you just need to multiply this with the portfolio value to arrive at value at risk number. So if you see here, the value at risk number is nothing but we are trying to calculate 1 day value at risk at 95% confidence interval, which is $24,161. And same goes for 90%. So once we have 90% of 90%, right, of certainty, if we are considering, so your uncertainty will be 10%. And as I said, certainty period and your uncertainty should combine with should add up to 100%. So once you basically take the uncertainty, you multiply your total number of data points with your uncertainty, and then you round it up, right? So now a lot of people have I have read a lot of research papers on historical method. And sometimes people, when they round it, some people consider round up, and some other people just take a round. So when you just consider a round, right, this will become 25 and not 26. So it depends on you, on person to person, and on like uh, how you want. But what I'm considering, just to make it standard, just to make the process standardizes, I'm just rounding it up. So once I round it up, this becomes 26. So you need to find the return at 26%. You need to find what is your return at 26 position, which is nothing but negative 1.9%. Multiply this with your portfolio value, and you will arrive at your value at risk number. So this value at risk is nothing but your 1 day 90% value at risk. So what I have done is, just for a visual representation, I have just taken a histogram plot. So I've just used a histogram plot and just edited, okay, what will be the value at risk at 99% confidence interval, 95% and 90%. So you one thing that you will observe is the more confident we are. Let's say if you see 99%, right, the higher the loss, and the lesser the confident are, the lower the loss, right? Because once your confidence interval, um once your confidence interval, once you, let's say, take 90% confidence interval, so you're moving away from the tail, right? So if you see, you're moving on this side, right? So that is why you will always feel like, and that is the notion also, right? Whenever higher the confidence interval, higher will be the potential loss. So this was all about the value at risk using the historical method. I hope you understood this method. Please let me know if in case you have any doubts. Also, I have also highlighted the step. I'll be uploading this Excel once I complete all my videos. So you can refer to this. You can refer to this Excel just for a better understanding. Also, if you see here, I've just used 252, so it will be 251, because we have total number of 251 data point. So just adjust this, right? Just adjust this, or once I upload it, I'll make sure I'll adjust this. But if you see this calculation, this is like the perfect calculation. So I hope you understood how to calculate value at risk using the variance covariance method, using the historical method. So okay, and in our next video, let's understand how to do value at risk using the Monte Carlo method. Thank you so much.